All right, guys, welcome to class today. We're in for an enjoyable one. We are talking about the difference between probability and odds, and this should be a little bit of a review from Math 7. Probability, you know some standard things about probability. As we have discussed already in this unit, probability is a ratio. It is a ratio of the number of outcomes that you want, or what we'll call favorable outcomes. If you listen to Khan Academy videos, he calls it something a little bit different, a little more complicated. Favorable, the ones that we are looking for, to the number of possible outcomes. And we just spent 2 or 3 days talking about a couple different ways to find the possible outcomes. So you've got Mr. Coin here, and you're talking about, okay, what is the probability that Mr. Coin, if we flip him upside down and all around, what is the probability that he lands on heads as he is walking right now? Well, there is how many heads are on the face of a coin. The probability of that event, let me bring here, is the favorable outcome, the number of heads on the coin, and that is 1, to the number of possible outcomes. And how many things are possible when you flip a coin? Well, 2. So you've got the probability of this event, or P of E algebraically, the probability of heads, as we'll say, the probability of heads is 1/2. But there's another way that you could represent that. You could also say as a decimal, 0.5. You could also say as a percentage, it is 50%. And I hope that is a little bit of a review once you are at pre-algebra, okay, of simple probability. You have a 50% chance of landing on heads, or a 1 in 2 chance of landing on heads when you flip a coin. Now, what about a red 3 from a deck of cards? If you know anything about a deck of cards, there are 52 possible outcomes. And how many red 3s are there? Well, there's not only the 3 of hearts that is depicted here. There's the 3 of hearts, but there's also the 3 of diamonds, which also would be red. So how many cards is that total? Well, there's 2 red 3s out of a total of 52. And can that fraction be reduced? It can. Right, we'll divide them both by 2. We get ourselves 1 out of 26. So there is a 1 in 26 chance of pulling a red 3, meaning that if you were to sit there with a deck of cards, shuffle them up really good, and start pulling cards, you would get a red 3 1 out of every 26 trials, theoretically. Okay, that is probability, the ratio of the number of favorable outcomes to the number of possible outcomes. So this problem says, what is the probability of rolling an even number on one single die? An even number. Well, let's think about the even numbers on the die. You've got the 2. You've got the 6. And you have the 4. And I have no idea why I went out of order, but I did. Okay, you've got the 2, the 4, and the 6. That is how many outcomes? Well, you've got 3 that are possible. And if you know on a standard cubic die, a number cube, okay, you will have 6 possible outcomes. So 3 out of 6, once again, reduces to 1 out of 2. And there is a 0.5 or 50% chance of that happening. So if you were to roll it 100 times, theoretically, you should get somewhere around 50% of the outcomes to be an even number. If you were to roll it 1,000,000 times or 1,000,000,000 times, it's probably pretty close that there's going to be the probability of even is going to be pretty close to 50.0%. Okay. Now, odds is something a little bit different, okay? And you often talk about odds if you are in the gambling world or something like that. Odds is a ratio of the number of favorable outcomes to the number of unfavorable outcomes. It's still a ratio, but this one's a little bit different, okay? Odds is the number of favorable outcomes to the number of unfavorable outcomes. So let's talk about our coin again. On a coin, and I'll do my best to draw. Okay, there's the silhouette of Mr. Lincoln or something like that. Okay, here's our coin. What are the odds of getting heads on a coin? Okay, when you flip a coin, it's fair. So you've got odds of heads. Well, how many heads are on the coin? Well, there's 1. And how many not heads are on the coin? How many outcomes are available that do not meet the criteria, that are not favorable? Well, there's one tail. So in this case, it's a ratio of 1 to 1. Okay. You're going to see on the next problem, it's going to represent that in a fraction. And I would rather you not represent that in a fraction because it gets a little bit confusing because the second number is not a total. It's not the total. It's not 1 out of a total of 1. And you do not want to represent them in a percentage. It is the second number is just simply the other outcomes, right? So what are the odds of getting a number less than 3 on a die? So let's think about the numbers that are less than 3. You've got 1, you've got 2, and is 3 less than 3? Well, to meet that constraint, you would have to have a number that is less than 3, and 3 is 3, so 3 does not count. So we have 2 favorable outcomes, and how many are unfavorable? So, well, if you've got 2 favorable, that leaves you with 4 that you're not looking for. So 2 to 4, that odds can reduce to is 1 to 2. And you do not want to say 50% or half, because that indicates that half of the outcomes are less than 3, and that's not true, right? This second number is not a whole, so we do not want to represent it. I have a pet peeve of representing odds as a fraction, so I do not want you to represent it as a ratio with the colon, and we should be good to go. So odds is, and this is going to pop up as 2 over 4, and I don't like putting it over 4. Okay. So the last problem here says, find the odds of picking a blue marble from the bag. And if you have this printed out, you're not going to be able to tell which ones are blue and which ones are not. But you can see up here on the screen that we do definitively have some blue marbles in the bag. Okay, and we can count them. We've got 1, 2, 3, 4, 5. 5 favorable outcomes, and we have to figure out how many are total here. So we've got 1, 2, 3, 4, 5. And then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total. But what are the odds? There are 5 favorable outcomes, ones that we're looking for. And there's not 16 total. We don't want to say that the unfavorable outcomes is 16. We want to say that there are 11 that are not blue. So 5 that are blue. And we've got 11 that are not blue. Okay, they do not meet the constraint. And it's as simple as that. It's as simple as counting, okay, for odds. So there you have it. There's the difference between probability and odds.